Welcome to Everything You Always Wanted to Know About Excel, but were afraid to ask. This is Lesson 9, Tables, Charts, and Graphs. Here's what you'll need for this lesson. Microsoft Excel 2016 or newer, or Excel 365. This lesson's example files. Speakers or headphones. And ideally at least 2 monitors. Here's what you'll learn in this lesson. Excel tables. Charts and graphs, including line graphs, column graphs, pie charts, and area graphs. So, what exactly is a table? A table is just a structured container for your data. Any range of contiguous cells can be converted into a table. There are tons of advantages to using a table within Excel, including visual grouping of data, being able to reference data by the table name or column header rather than just a column letter. This is especially useful for large sets of data. Also, tables come with some easy formatting tools. And it's much easier to add calculated columns and to auto-calculate newly added rows. Let's have a look at how to create a table. Excel makes it very easy to convert any range of cells to a table. And there's a few different ways to do that. So in our example file, we're going to look at this tab, the New York Times tab. And in here we have all the dates of this year so far. And then in this column, we have the number of articles that the New York Times published on that day, published on their website on that day. And in column C, we have the number of articles published that day that reference the coronavirus. This is just any article that uses the word coronavirus. And we can see by kind of skimming this data that it's sort of ticked up over time. And we'll get more into that a little bit later. But what we want to do is take this range of data and turn it into a table. So there's 3 ways to do that. And we're going to look at all of them. The first one, on the Home tab, over in the Styles group, there's a button that says Format as Table. If you click that, you can choose from any of these formats, sort of prefab table formats that Excel has to offer. And we're going to choose this one, just to be a little different. And when you do that, Excel is going to highlight the area that it thinks, it'll try and detect the range of cells you're trying to turn into a table. And, you know, it's always a good idea to just look at it and make sure this little green line covers everything you want to be in your table and doesn't include anything that you don't want in your table. And in this case, everything looks good here. Also, we want to make sure that the My Table has headers option is checked. You can see that we do have column labels, column headers for our data. So we want to make sure that My Table has headers is checked. And then we're going to hit OK. And you can see that turns this into a table. There's a few things I want to show you about what that does. First of all, now that it's a table, our little Table Tools context menu appears up here on the ribbon. Notice when I'm in just a regular range of cells, that menu doesn't appear. But anytime I click in a table, the Table Tools menu is going to appear on the ribbon. In that Table Tools design menu, you've got some different style options. And one of the things that's most recognizable about an Excel table is what's called banded rows. Every other row is a different color. But you can turn that on or off in a table. You could also choose to have banded columns instead of banded rows, or in addition to banded rows. You can also toggle on and off having a totals row. If you click here, this will add a totals row. Now, by default, Excel is only going to add a sum or a total into the rightmost column. But what you can do is actually choose which columns get totaled and which ones don't. So here, this is a sum. That's fine. We're going to leave that. But we want this to also be a sum. And so we actually can we just click in this cell and use this dropdown to choose what formula is applied in this totals row. We can average or count the number of rows. It's 148, which obviously just represents the number of days in this case. Or we can look at the max. So the most articles in a single day was 742. But most of the time, you're going to want the sum. Of course, if you choose something else for this totals row, you should also change the label on the totals row so that it reflects properly what is represented there. And you can also choose to bold or style separately the first column or the last column by checking either of those boxes. Now, one other thing you may have noticed as I was scrolling down the page is that our column headers replace the column letters up here when I scroll down out of view. So that can be pretty useful. That's kind of cool. And then a couple other things to mention. You can select an entire column minus the header and minus the totals row by clicking Control Space on your keyboard. So if you need to make any changes to a column, you can do it that way. Now, I mentioned there are 3 different ways to make a range into a table. So I'm going to show you the other 2. So the other 2 ways to change a range of cells to a table, on the Insert tab, you can click Table. And again, you're going to get that same dialog box, which is going to allow you to select your area and then hit OK and turn it into a table. Now, if you use that, it's not going to ask you in advance how you want to format your table. So you'll have to wait until after you've created your table, and then you can use the different options here on the Design tab to select your table styles or to define a new table style. And the final way to convert a range to a table is simply to hit Control-T on your keyboard. And that's, again, going to bring up the Create Table dialog box. Again, it's going to default to this blue and white look. And again, you can just go ahead and style that however you want after your table has been created. Now, once you've converted your range to a table, there's a few more things we want to do. But the first one is that we're going to name our table. The reason we do this is Excel is just going to automatically give it a name like Table 1 or Table 7, depending on depending on how many tables have ever been in the document that you're using. So By the time you get this example file, you'll probably be dealing with table 8 or 9 or 10 or something like that, because I've been playing around with this document for a while. So don't worry about what it says right now, but what you're going to do is just change the name of this table to something that you can remember, so that later on when we need to reference this table, we can do so pretty easily. So to do that, on the Table Tools Design tab on your ribbon, all the way to the left is this table name. And if you just click in there, you can name this table whatever you want. You can only use letters, numbers, and underscores. No other characters are allowed. So we're going to call this COVID data. So as I mentioned before, one of the key benefits of using a table is the ability to easily add calculated columns. So actually later on in this lesson, we're going to come back and use this data again. And when we do, there's a couple more columns we're going to need. So let's have a look at how to add a column to a table. It's actually very simple because Excel is going to infer that when you add data adjacent to a table, it's going to infer that that data is part of the table. So if I type a column header right here in column D, it's going to automatically add a column to the table. Now, what we have currently is the number of articles per day and the number of articles per day with coronavirus referenced. But later on, when we make a graph of this, we're going to need to know the number of articles without coronavirus referenced. And so the way we're going to do that is adding a column for non-coronavirus articles. And you can see that it automatically extends that formatting to the new column. So to get at the non-coronavirus articles, all we're going to do is subtract articles per day minus the number of articles that reference coronavirus. And we're going to look a little bit more in depth into how to do cell references within tables in a moment. So don't focus too much on the syntax, because really we can do exactly what we usually do, which is just click the cell we're trying to reference. So in this case, it's articles per day minus coronavirus articles. Now, there's some weird symbols in there we're not used to seeing in formulas, and that's fine. Don't focus too much on that. But you can already kind of see that when we look at this formula, it's a lot easier to figure out what it's doing than the formulas we're used to writing, that would normally say B2 minus B minus C2, which can be confusing, especially with large sets of data. Here, we're roughly saying articles per day minus coronavirus articles. So it makes our formulas a little more human readable. And it makes troubleshooting a little bit better too when we're referencing data within tables. So when I hit enter, I'm not going to have to drag this formula down, because when I hit enter, it's automatically going to apply to every row in my data. And again, that's one of the big advantages of dealing with a table. And the flip side of that is that when I add the next day worth of data to this, whatever that may be, as soon as I type in this row, you'll see it adds the formatting to that row, that new row. And as soon as I write numbers in these two cells, in these two columns, this formula that we wrote up above has already extended to the new row. So we're going to delete that because it's fake data. The rest of this is real data. And again, we can write any kind of formula we want here. We can also look at, for example, if we wanted to know what percentage of articles reference the coronavirus, we could look at coronavirus articles divided by articles per day. And then hit Control Space to select that whole column and turn it into a percentage. So again, now you can sort of see, like, we went from 0% in January to about 10%, 10 to 15% in February, to as high as 60 or 70, nearly 80% in March. 80% of all articles that the New York Times published referencing the coronavirus. Now that we know how to make a table, let's familiarize ourselves with some table terminology. First, we have a column. That one you already know. But then the table itself is divided into 3 parts, which can be referenced separately. The headers, the data, and the totals. Each of these parts can be referenced within your formulas. Let's look at how to write some formulas that reference tables. Here's an example of how you reference data in tables. The reference contains up to 3 parts: table name, the range identifier or identifiers, which correspond to the parts of the table we covered earlier, the data, the headers, the totals, or all 3, and the column or columns referenced. You can also make your reference apply just to the current row by adding the @ symbol inside of the first set of square brackets. So now that we've looked at some of the syntax surrounding references to tables, I just want to go through kind of a practical demonstration of it. Again, don't worry too much about memorizing. Don't memorize any of that. It's important to know what you're looking at. It's important when you see those square brackets or that @ symbol to know, oh yeah, okay, this is obviously referencing a table. But as far as trying to memorize any of that, don't bother. It's very simple to just write formulas or populate functions using that data. So, for example, looking at our New York Times articles here, it's very simple to just write a formula that adds together everything in the articles per day column. We would use a simple sum function. And the data that we're summing is going to be a column. It's going to be in a table. So we just reference the table name, which is, as soon as I start typing it, you can see that COVID data shows up in the auto suggestions here, the autocomplete suggestions. And it's got a little table icon, so you know that what we're looking at here is a table. So I'm going to go ahead and double click on that. And now we know we're looking at COVID data, that's the table. And then I'm just going to type a square bracket, and it's going to prompt me with all of the different options for what I could type here. Now I want to sum just the data portion of the articles per day column. So Excel is going to default to using the data portion, so I'm not going to even bother mentioning that I want the data portion there. And I'm just going to choose the articles per day column and hit enter. And that's going to show me all of the, that's the total of the number of articles published so far this year, basically. Now, even if I add back in, I don't think I have a totals row in here right now, but if I were to add it back in and to include the sum there, 25,483, that should match, which it does. And notice that even though I haven't specified, Excel is defaulted to just showing me the data. If I wanted to include, for some bizarre reason, more than just the data, I could include the data and the totals. In that column. And that's going to, it's going to double the number. It's going to be 50,000 because it's now adding all of this, including our totals row. That's not really something we want. So I'm going to go ahead and remove that. And we can go back to this number. But you're now able to reference an entire column of data pretty simply and in a sort of readable. The other thing I mentioned is that you can reference the data from a specific row in your formula. And the way we do that is, again, we're just referencing the name of the table. And then inside that first set of square brackets, we're putting a @ symbol. And then selecting our column that we want to reference. So in this case, let's do %. And since we're only referencing that one column or that one row, you'll see that as we drag this down, it's going to act sort of like a normal reference and reference the specific row in that column. Graphs allow you to visually represent your data in a way that's easier to understand and consume. Excel has 17 different types of graphs and several variations on each type. Now, we don't have time to cover all 17 in this lesson, so we're just going to look at 4 very common, useful types of graphs. It's important to select the right type of graph for the data you're trying to represent. We use a line graph when we want to show how quantities change over time. An x-axis of a line graph always should be numerical. With a column graph, we're trying to compare discontinuous quantities. So the x-axis of a column graph is usually non-numerical. A pie chart is used to show how parts of a whole are allocated. So a good rule of thumb is don't use a pie chart unless the quantities in your chart add up to 100%. And finally, we'll look at stacked area graphs. An area graph combines the quantity comparison of a pie chart with the change over time dimension of a line graph. So for our line graph, we're going to use this tab here, the Home Runs tab. And what we have in here is the number of home runs hit by each of the teams in the National League East over the past 10 seasons. And basically, we're just going to insert, we want to look at a line graph so we can see how each team has kind of improved or unimproved over time. So the way we're going to do that, we're going to go to the Insert tab. And you'll see there's like a whole charts group here right in the middle. And we're looking at line graphs. Now, you can click anywhere in this data and see what kind of chart it's going to insert. It's not going to detect the data. A lot of times it's not going to detect the data properly, especially when you have things that are numbers here and things that look like numbers, even though they're years, up here. So that's okay. There's a few ways to deal with that, and this is mostly the correct data. So we're just going to click that. Again, notice that it's thinking that these years are part of our data, and that's not correct. But we can fix that. All we have to do is just drag this down. There we go. So now we've got the correct number of home runs per team per year, but our data isn't labeled properly. So what we want here on this x-axis is the years, now that we've removed it from the data. So how do we get that? Up on the ribbon, there's a new Chart Tools tab, and under that we have a Design tab. So if you click the Design tab and then click Select Data, you'll see all of your data series. That's each of these different colored lines is a data series. You'll see each of these data series over here, and you can edit it over here if you want to, if you need to. But over here on our horizontal or category axis, we've just got like a 1, 2, 3, 4, 5. It's just generic because it doesn't know what to do. So we're going to fix that. We're going to hit Edit, and we're just going to select our axis labels and hit OK. And now we see the years 2010 through 2019. So that's a lot better. But this chart's still missing a few key things. One of them is every team hit between about 95 home runs, between about 95 home runs and about 200, 250 home runs. So we don't really need this wide of an axis. And in fact, the y-axis being, going from 0 to 300 kind of makes all of our data very smushed in the middle. So one thing we might want to do here is click on this y-axis and select Format Axis. And that's going to go ahead and let us choose the upper and lower bounds of the axis. So in this case, the lowest number in here is the 2013 Miami Marlins only hit 95 home runs. So we're going to put the minimum at 90. And we're going to set the maximum, a lot of home runs last year. We're going to set the maximum to 250. All right, so now this data is a little more interesting. You can see, the Mets kind of coming from the bottom all the way up to the top. You can see the Marlins pretty much staying on the bottom the whole time. It's kind of some interesting data. There are a couple more options for how we can format this chart. First of all, every good chart deserves a title, and that title should be descriptive of what's in the data and of the time period that it covers. So in this case, our chart is NL East home runs per season, 2010 through 2019. And another thing we're missing on this chart is some labels for our axes. So there's a whole bunch of different optional elements you can add to any chart. And the way to do that is on this design tab, once again, there's an add chart element button. And you can add axis titles. So here we're going to add a horizontal axis title. Double click in there. And this is season. And then we're going to add a vertical axis title. And this is home runs per team. Now we already have a legend, but we're able to use this tool to move that legend wherever we want. Very commonly, it looks good on the right, but here it looks pretty good on the bottom. So we're just going to leave it where it is. You can also add or remove grid lines. You can see this already had major grid lines, but you can add minor grid lines as well, or add vertical grid lines to more easily see what year we're looking at, for example. We already have a chart title, and now we have axis titles. So that's pretty much everything that's relevant to this. Now, the last thing I want to mention with the line graph is, this looks pretty good here. If I want to present this data as here's my data and here's my chart, then this is fine the way it is. But another option that you have anytime you're working with a graph is to create that graph or move that graph to another location. A graph can be its own tab. So the way we would do that is just right-click on the graph and click Move Chart. Right now it is an object in Home Runs. You can move it to any other existing tab here. Or you can create a new sheet for it. We're going to create a new sheet for it. Home Run Charts. And if you're printing this or presenting it as its own kind of thing, this is your best bet. This is the way you're going to make it look the best because you can read it more easily. It's larger when it's in its own chart and when it's in its own tab, rather. And, that makes it kind of easier to read and dissect. The other thing that's worth mentioning here is that you can, when you're looking at just the chart and not the data, you can still figure out what each individual data point is by clicking. You can see, by clicking on any line, you can see where the different data points are. And hovering over each data point, you can see the data for that data point. So this is the 2010 Philadelphia Phillies, and they hit 224 home runs. And they are pretty much only beaten by, they're tied by the 2017 Mets, and they're beaten by almost everybody. They're beaten by the Nationals and the Mets and the Braves in 2019. Big year for home runs, 2019. So that's it for line graphs. Next, we're going to look at a column graph. For a column graph, we're going to go to the Broadway tab. Now, I mentioned that a column graph is used to compare discontinuous quantities. That means basically that the value on your bottom axis, your x-axis, is not it's not numerical, or if it is numerical, it's not continuous. It's a category, not not a view of a change over time. So here we have a good example for that. This is the 14 longest running Broadway shows, and the number of performances that each show ran for. Now, this is a perfect example for a column graph. So the way we insert a column graph, again, it's exactly the same as before. We're looking at here, a column graph. And when we're only using one set of data like this, it doesn't matter if you choose a clustered or a stacked column graph, because you're going to get the same data. So this is the number of performances that each of the 14 longest running shows in Broadway history has run for. Now, one thing that bothers me immediately about this graph is the number formatting of this column here. I want, a comma to do my thousands separator, because that's going to make it a little bit easier to read. So I have a couple options here. I can go ahead and go back and format this data. That's probably the easiest way, especially with a small amount of data like this. But the other option is to right-click on the axis and select Format Axis again. And then down at the bottom here where it says number, I can go ahead and select the formatting that I want. And that's going to apply that formatting now without me having to mess with my original data, which is useful if I don't have access to change my original data, or for whatever reason I want the formatting on the graph to be different from the formatting of the original data. And this is longest running Broadway shows, Broadway musicals. And again, we're going to add axis titles. You always want to have axis titles. Because they make your data more cohesive, more coherent. Now, in addition to all of the, adding data elements and things like that, you can also format, you can change the colors and backgrounds of things. But one of the things that I like now in the newer versions of Excel is that Excel gives you some sort of prefab suggestions for how you might want to make your graph look. Now, I don't care for all of these, but some of them are pretty nice. I like this one. And I'm a big fan of the dark ones. I think they're easier to read. So you can go ahead and choose from these different chart styles. Or you can, choose one and then modify it however you want. For example, I can change the colors on this. Or I can go ahead and click on any individual bar and change the colors just for that by selecting a different fill color here. That might be useful, for example, if you want one data series to stand out from another. Now I'm going to go ahead and move this to another tab again, just because that gives me a better look at it here. And a couple other chart elements that might be worth mentioning. One thing I like to add is data labels. So for something like this, again, we all know that when we're looking at this in Excel, we can hover over any of these and view the actual data values. I can see that a chorus line ran for 6,137 performances, for example. All of that is great, but what if I'm printing this and I still want people to be able to see that data? So the way we solve for that is we add another chart element and we add data labels. So in this case, we're going to add them here to the outside end. And you can see they're formatted the way the original data is formatted. We can go ahead and fix that once again by formatting the data labels the same way we did for the axis. So now when I print this, people are going to be able to see the number of performances that each of these ran for. If you don't like data labels, you can also add, you can remove those, and you can also add a data table instead. And that just shows that same data, but right underneath here. So that people can reference that if they need to. Next up, we're going to look at a pie chart. So for that, we're going to go to the Beatles tab. And here we have, of the 219 songs that the Beatles recorded throughout their career, this is who composed, how many each composer wrote. You can see 170 of them were written by Lennon and McCartney. They had a deal where they listed each other as co-writers on every song they did. So Lennon and McCartney, that's 170 songs. And George Harrison wrote 22 songs, and Ringo, he wrote 2 songs. And then there are 25 songs that the Beatles recorded that were covers of songs written by other artists. Everyone from Chuck Berry to Carole King. So we're just grouping those together in other. So now we're going to turn this into a pie chart. And again, this is very similar to everything else we've done, but the way we do this is we just select our data. And we're going to click Insert. And here's the pie chart. And some people are really into these 3D pie charts, but I'm just going to go with a regular pie chart. And I'm going to go ahead and move this to a new tab. So once again, always make sure to label your data. And one thing that we saw in the last type of chart was data labels. Here, instead of just a data label that shows the number of songs, we might want to add the percentage. So in order to do that, we add our data labels, and then we're going to go ahead and click Format Data Labels again. And we can select what the data label includes. So we could include the category name here. For example, if we wanted to get rid of the legend, and we could also include the percentage. So from this, you can see that Ringo wrote 1% of the songs they recorded, and George wrote 10%, and other composers wrote 11%, and John Lennon and Paul McCartney, they actually wrote 78% of the songs that the Beatles recorded across all their albums. And this pie chart is actually a better example of this change colors option, because unlike the column chart where everything was all one color by default, this defaults to having a bunch of different colors. So you can kind of see some of the built-in themes that Excel offers. Some of them are better than others, if you ask me. And be wary of these color scale ones if you've got a lot of data and if you are using a legend, because we're labeling these right next to them, it doesn't really matter that this color and this color are hard to tell apart. But if you were using a legend and not using data labels, you probably would want to avoid a color scale like this, because some people might have trouble telling, this green from the next darkest green. Finally, we're going to look at a very specific type of area chart, a stacked area chart. And for that, we're going to go back to our New York Times tab. So one of the reasons I included this data is because I think it will illustrate something pretty cool when we make this type of graph with it. So looking at this data, we're going to once again click Insert, and then from the Line or Area Chart button, we're going to choose a 2D area chart, and we're going to choose the 100% stacked area chart. So I'm going to click that, and it's going to default to including all of our columns here. That's not actually what we want. We've given it the two columns we want really are the coronavirus articles versus the non-coronavirus articles. So again, we're going to go into Select Data, and we're just going to remove the things we don't want. We don't want articles per day, because we just want coronavirus and non-coronavirus articles. Now, this kind of area graph, it sort of combines the pie chart that we looked at before with the line graph that we looked at first. And I'll tell you what I mean by that. Essentially, every one of these dates on here is the equivalent of its own pie chart. So I'm going to move this to another tab. And you can see each of these like stripes essentially represents one day. and the gray represents articles that were not about coronavirus, and the orange represents articles that did reference the coronavirus. And you could make a series of pie charts. For example, I could take a specific day and make a pie chart out of it. For example, we have let's look at this day here, right? We had 152 COVID articles and 33 non-COVID articles. And we could turn that into a pie chart and look at what that looks like. We could go ahead and do that 148 times and look at every different pie chart. But obviously that's not an easy or useful way to consume that data. And so what we're able to do here is view that data still as a percentage of the whole. Notice again that the x-axis, or the y-axis, is a percentage. But we're able to view it as a percentage of the whole changing over time. And so that's kind of the advantage of a stacked 100% area graph like that. Let's review what we learned in this lesson. We learned all about Excel tables. And we looked at several different types of charts and graphs, including line graphs, column graphs, pie charts, and area graphs. Thanks for watching. We'll see you next time.